Geometry, Lesson 7.2, we'll be talking about areas of other quadrilaterals. We're going to do a couple of opener problems just to get us acquainted with some of the things we've already learned and how to use them. Find the area of each quadrilateral by finding the sum of the triangular areas. So far what we've been using is the properties that we know about triangles to solve some problems. We can see in this drawing right here, which is a rhombus, you can see it has 4 congruent sides. Its diagonals bisect each other, so we have 4 90-degree angles, and each diagonal is bisected in half. So we have lengths of 7, or I should say heights of 7 in each triangle, and bases of 3. So let's go ahead and find the area, and what we'll do is solve the area of one triangle and then multiply it by 4. So we have area equals base times height divided by 2, or if you're more comfortable with it, 1/2 base times height. We have a base length of 3 and a height of 7, so that's inserted into this formula. And let's just start with this triangle right here. And 3 times 7 is 21 divided by 2 is 10.5 units squared. If you feel lost, let's go back to the basics, and we have 4 separate triangles in this figure. Each one of these triangles will have the same base length and the same height. So what we can do is solve one formula and multiply it by 4. 4 times 10.5 units squared, which was the answer from the second step, is 42 units squared. Remember, with these problems, when we're talking about the solution for an area, you will have units squared. Find the area of each quadrilateral by finding the sum of the triangular areas. This is a kite. One of the properties of the kite is that the diagonals form 90-degree angles, that the crossbar is divided in half, so it's bisected by the diagonal, the other diagonal. So we have a crossbar here with a total of 12, so 2 sides of 6, and in this triangle you can see that there's a base of 6 and a height of 11. Here we have a base of 6 and a height of 11. For the top 2 triangles, we have lengths of 6, which are their base, and we have congruency marks to show that the height will also be 6. So let's solve. We'll use the formula for an area of a triangle, but because all 4 of these triangles are not congruent, we'll solve for 2 congruent triangles and then 2 more congruent triangles. How do I know they're congruent? Well, let's take a look. This triangle right here has 2 congruency marks on this side. It has the height and it has the base. We already know the base is congruent to this base. The height is shared by both triangles, and the long side, or the hypotenuse in this case, has 2 congruency marks. So we know that these 2 bottom triangles are congruent, and they're congruent by side, side, side. The top 2 triangles are also congruent by side, side, side. You have the hypotenuse on both triangles, which is congruent. They share the piece for the height, so that's congruent, and the length of 6 is congruent also. So let's solve the two larger triangles. Area equals base, which is 6, times height, which is 11, divided by 2. That's 66 divided by 2 is 33 units squared. The top triangles are 6 for the base times the height 6, which is 36 divided by 2, which is 18 units squared. And there are 2 of each of them, so 2 times 33 is 66, 2 times 18 is 36, and we have 102 units squared when they're added together. Now, one of the things that you're going to notice when you're solving some of these triangles is that you can see right away that if you're dividing by 2 and then you need to multiply by 2, they will cross cancel each other out. If you're very good at algebra, you can do that early on. However, I encourage you to do all the steps if you have any feelings of insecurity about that, or if you notice that you're getting these wrong frequently. Let's do one more. Find the area of each quadrilateral by the sum of the triangular areas. This quad appears to be an isosceles trapezoid, but we don't know. We do have a diagonal. It creates a triangle on top here that has one side of 10, and another triangle on the bottom here that has a base of 10 and a height of 7. So we have two triangles to solve for. I went ahead and I labeled them A1 and A2. And A2 is very easy to see. So A2 is base times height divided by 2, which would be the base of 18, times 7, which is 56, 18 times 7 is 126 units squared divided by 2, which will be 63 units squared. So that is for this triangle, and there's the height. Now for the top triangle, we will use the same height. We have a base of 10, so 10 times 7 is 70 divided by 2, which is 35 units squared. If we add both of the answers together, 35 and 63 equals 98 units squared. So once again, we have two triangles, A1 and A2. We solve for both. Let's go to our first theorem. One of the things we'll begin doing in this lesson is we'll learn how to derive formulas. You should have a little experience with this in algebra, but it's been a while. We could go on adding triangles, but formulas shorten the time it takes to solve a problem. So first, before we begin, let's look at this trapezoid. It's obviously not isosceles. You can see the two triangles that the diagonal creates, and it shows you a height, and you have base 1, which is xy, and base 2, which is yz. They have the triangles labeled A1 and A2. So the area of a trapezoid is 1/2 the product of its height and the sum of the length of its bases. So here is the formula for area of a trapezoid. The formula is 1/2 times the height times both of the bases added together, base 1 plus base 2. So let's derive the formula for this by using the triangles. We start with the area of the whole trapezoid, which is W, X, Y, and Z. It equals the area of triangle XYZ, and the area of triangle WXZ. One thing that would be helpful is if you draw this, label it, and you'll begin to be able to see more clearly how this formula works. Now what we're going to do is we're going to substitute our known values for the callouts on the triangles, or the names of the triangles in the trapezoid. So the area equals, and we have two triangles here, so remember it's base times height. So if we take the first triangle, XYZ, the base is labeled base 1. So 1/2 base 1 times the height. And then we'll use the area of the second triangle, 1/2 base 2 times the height. So those are the two formulas for the triangles that would be added together. Now, because we have some common terms in here, we're going to use distributive property to make this a more readable formula. So we have 1/2 in both of these triangles, so we'll pull that to the outside. We have height in both of the triangles, we pull that to the outside. We now create parentheses, and what's left is base 1 plus base 2. And there is your formula, and that's called deriving the formula. Example 1, find the area of each side of a popcorn box if its sides are 6 inches tall, its top edges are 4.25 inches, and its bottom edges are 3.25. So there they are. There's our sketch that we need to make. And here's our formula. 1/2 height times base 1 plus base 2. We substitute height of 6 inches and bases of 4.25 and 3.25, and we multiply within parentheses first, and then we end up with 22.5 inches. Just a hint on this formula, if you sometimes get confused between this one and the next one we're going to learn, a trapezoid, we're actually, without the h in the formula, you actually have the formula for an average. So what you're actually doing is adding the two bases, dividing them by 2, and then multiplying by the height. Area of a kite is our next theorem. It's 1/2 the product of the length of its diagonals. So looking at our kite figure, you can see we have two diagonals, PR, which we're calling diagonal 1, and QS, which is diagonal 2. Because of the diagonals that are drawn, the crossbar is divided in half, and we have 1/2 diameter 2 for both segments. We're going to substitute our values that we now have into our two triangle formulas. We'll be adding the triangles' areas together. So 1/2 base times height plus 1/2 base times height. For the base, we are going to use diameter 1. And for the height, on the top one, it'll be 1/2 diameter 2. And it will also be 1/2 diameter 2 for the second triangle. Both of these triangles happen to be congruent. We'll take our answer, 1/2 times 1/2 is 1/4. We have diameter 1 times diameter 2, plus the congruent triangle, 1/4 diameter 1 times diameter 2. Add those together and you end up with 1/2 diameter 1 times diameter 2, which is our formula. Example 2, we're going to find the area of a kite. This one's just a little different because we have mixed units. So first thing we need to do is convert millimeters to centimeters. You can convert centimeters to millimeters, but you'll end up with a large number, and that's not my preference. So remember, to convert, you want to have the desired unit left on the top. So that way you can cross cancel out the millimeters. You go ahead and cross cancel those out, multiply across, you have 115 times 1 divided by 10, which is 11.5. So let's input our information into our formula, and we have 1/2 diameter 1 times diameter 2. And I guess we'll be calling the crossbar diameter 1, so there'll be the diameter 1, the piece we solved was 11.5 centimeters. There are 2 of them, so 2 times 11.5 times diameter 2, which is 13 plus 30. 1/2 times 23 times 43 is 494.5 centimeters squared. Just a little hint, because the diagonals of a rhombus are perpendicular bisectors of each other, the formula used for the area of a kite can also be used for a rhombus. That brings us to our next theorem. The area of a rhombus is 1/2 the product of its lengths and its diagonals, 1/2 diameter 1 and diameter 2. So there's one formula that will cover 2 figures if you have the right information. There's actually another area formula for a rhombus, but it just depends on what information you have. Let's just review the qualities of a rhombus. It has parallel sides, so opposite parallel sides. The opposite angles are congruent. Consecutive angles equal 180, they're supplementary. Sides are congruent by definition, so all of these sides are congruent. Diagonals bisect the angles, so each one of these angles in the vertex is bisected, and diagonals are perpendicular bisectors of each other. That means we have 4 90-degree angles in the center of the rhombus. Example 3, find the height of the rhombus ABCD. Let's look at this figure, and we have a rhombus. We have 2 diagonals drawn, and then we've dropped a height. So let's go ahead and fill in some missing lengths that we need here. I like to do this just to keep things straight in my head. I've gone ahead and added the other side of the measurements here. This whole diagonal is 8, this whole diagonal is 6, and each side is 5. This can get confusing when you're working these problems, so it helps. So what we're going to do is we're going to use the diagonals to find the area of the rhombus. Then we're going to substitute the area and the length of the base into the formula for the area of a parallelogram. And we're going to solve the equation to find the height. So we're not solving the area, we're solving the height. So we're going to take the area of a triangle, and we're substituting what we know. We just solved for area of the whole rhombus. We'll put this right here, and the area is 24 meters squared equals the base, which is 5, times the height. The height will be 24 divided by 5, which equals 4.45 meters, or 4.8. My preference is that you use decimals and that you only go to tenths. So you'll only go one spot past the decimal. So to find the height of a rhombus, once again, you'll find its total area, and then you'll substitute that into the height of into the area in the formula for a parallelogram, base times height. Example 4. This one's kind of difficult, so what I want you to do is get some graph paper, draw this figure. Well, stop the video so that you can see it. Draw the figure and then come back. So we're going to find the area of the quadrilateral, and we have these points. So we have point W is 4 and 1, X is 1, negative 3, Y is negative 2, 1, and Z is 1, 5. Now looking at this figure appears to be a rhombus. Let's go ahead and draw diagonals to confirm this point. So stop the video and draw a diagonal from Z to X and from Y to W. Now if you had your figure correctly drawn on the graph, these lines should cross at the corner of a square, at the vertex of a square, and should divide the crossbar in half and create two congruent triangles. So the fact that diagonals are perpendicular bisectors of each other confirms that this is a rhombus. So because these diagonals meet at this corner of the square, you have them surrounded by 4 90-degree squares, and this is a rhombus. So what we want to do is find the length of each diagonal. Substitute that length, or those lengths, into the formula and simplify. So the first thing that we note is that, number 1, the slope of YW is 0. It's a straight line, so it's 0. And the slope of XZ is straight up and down or vertical, which means it is undefined. Let me move that over here. And XZ equals 8. Now, how do you know it equals 8? You have two ways to do this. You could give it a quick count on your graph, or what you can do is go ahead and do the distance formula, which is what you're really supposed to do to solve this. If you can't remember what the distance formula is, grab your notes. This should be something you should be able to get out of your notebook quickly and solve for the length of XZ, and then solve for the length of WY. You'll find that your answer should be 8 and 6. So these will be the lengths of your two diameters, and you substitute those values, and you will have 24 units squared. So go ahead and use the distance formula, and then solve for your problem. Now we'll be doing quite a few of these, so you need to brush up on distance formula, and we will be doing more in class. So this is your homework. I'd like you to start doing something this semester. Please write the homework numbers on the top, right under where your name is on your paper. So it should say name, date, and I want to see the numbers of your homework. I've noticed that I have some people are leaving off maybe the last 6 or 7 problems, and this really does damage to your grade. Here's an example of how to solve. This is a simple find the area of a rhombus. It has a diagonal of 27 and a diagonal of 13. We substitute the values into the formula, multiply them together, divide by 2, and we have 175.5 centimeters squared. Here's another one, number 19. A little more sophisticated, but this is the formula for a trapezoid. And in this case, we already know the area, and we're to find the height. So we substitute area values into where A was. We have 1/2 height, and then we substitute the 17 for base 1 and the 25 for base 2. And then we go ahead and solve our operation. We add these together. It's 42 centimeters. 1/2 of 42 is 21. Times the height. And to solve for the height, we divide both sides by 21, and our height is 12 centimeters. Now, even though you have an area that has centimeters squared, if you're solving for pieces, your answer will be centimeters. That is because we're not just dividing by 21, we're dividing by 21 centimeters. So centimeters squared divided by centimeters leaves you centimeters. Number 21. This is a little more involved. We will be going over some of these in class. Find the height of a trapezoid with an area. Once again, we have the area of 63 feet squared. If its bases of 1 feet and if its bases are, 1 foot and 3 feet longer than its height. So here's our formula. What I'm doing is the height is h, so we know that one base is 1 foot more, so it's h plus 1. The other base is 3 feet more, so it's h plus 3. And we'll substitute those values into the equation. So we know the area is 63. We have 1/2 height. Base 1 then will become h plus 1, and base 2 will be h plus 3. The first thing I want to do is get rid of this 1/2. So I'm going to multiply by 2 on both sides, and we end up with 126. And over here we've taken our h plus 1 and added h plus 3, which makes 2h plus 4 times h. And when we go to multiply, we end up with an answer that should look somewhat familiar. 2h squared plus 4h equals 126. This is a quadratic equation. When we have quadratic equations, we set them to 0, and we solve for both answers. So what we do is subtract 126 from both sides to set it to 0. And now we look for anything that we can simplify, and we can divide all three of these terms by 2. And we end up with h squared plus 2h minus 63 equals 0. And we have to find the factors for this problem. It's been a while since you've done this, I know. The factors for negative 63 and for this quadratic equation is h minus 7 times h plus 9. So that means that if we solve h equals 7 and h also equals negative 9, and we only use positive properties for these problems, so our answer would be h equals 7. So our height is 7. So if you can't remember how to factor, I have a link here to review. Copy and paste the link into your browser. It's Math is Fun. And scroll down the page until you get to a heading that says a method for simple cases. And there's also a practice link there. It's just the type of practice where you start playing with values to try to help you remember how to factor. And it has some ideas for little tips and tricks. Everybody learns them differently, but we will be using this a lot, and so it's time to practice. So we'll also do this in the classroom. And if you need any help on your homework, be sure to contact me. I am available, and we'll talk to you again soon.